Okay, so I've seen some of our introductions. Oh, in Uganda, it's 9 p.m. All right. I've seen some of our introductions. Many of us are medical persons and okay, PhD students, infectious diseases. It's oh, Nepal. Kani, welcome. You're joining from Nepal. Okay, it's almost midnight. So sorry about that. Health economics, University of Pretoria, epidemiology, and demography. Okay, thank you for joining. All right, so I see that a lot of us are from different backgrounds. Okay, thank you for joining. Shah from Pakistan, South Africa. Okay, yes, let me up my voice. So no matter the background that you are coming from, this course will be beneficial to you in a way. In so far you are doing a longitudinal study, so far you are doing a cohort study that you are collecting data over a period of time and you are monitoring the time of on each event occurred. So for this course, we are going to just keep it at the introductory level. There are so many things that are quite deep a bit into a survival analysis, but it's because it's a 2 days course. And so after this training, you're going to have a very good introduction and know quite a lot. We are going to do some very serious practicals, either today or tomorrow. Okay, so the time is almost here. We will start right now. Okay, so welcome everyone. I don't know if you're comfortable if I put my video on, or are we okay like this? Are we good?
Yes, I'm good.
Okay.
Yes.
All right. Yeah. I hope you can see my slide. Yeah, okay. Yeah. So let me put my video on. So, okay. I hope so welcome to class. We are using STATA for this training. We are using STATA, not R, not Python, because over my years of experience in teaching and in mentoring people in data analytics and research and biostatistics, I found out that people are more comfortable with STATA because of the simple languages, the simple way of writing the code. R, I use R too, and I teach R, but over time I found out that people have more affinity towards STATA. So I'm always of the opinion that whichever software you use, the important thing is to get your analysis done and done properly. So so many people do not have a programming background, so it might be quite difficult to grasp. So for this training, we are using STATA. So because it's a short course, we didn't make provision for the software. So if you had the software, no problem. But if you don't have, you can. I think STATA is I can't remember the price now, but you can request it from their website and get your copy. So this is my name. I'm a doctoral research fellow with I'm primarily doing cancer research. I've done quite a lot of other studies, but my PhD is on cancer research, especially looking at the area of hello? Someone is speaking. Please, if you want to speak, just kindly raise your hand and I will allow you to speak.
Hello.
Hello?
నేను
All right, so just a minute, let me mute everyone. Please just mute yourself. If you want to speak, no problem, you can raise your hand and I'll permit you. So as I was saying, my area of focus is on pathway to care. of breast cancer in Nigeria. So that's my area. So I'm a research fellow with the Network of Oncology Research in Africa here, comprising of 5 countries: Nigeria, Germany, Ethiopia, Tanzania, and France. So I also teach data analytics at my leisure time. I mentor a lot of people in STATA and some other softwares. So welcome and thank you for joining once more. So this is my presentation outline. Before we go to the practicals, maybe by tomorrow, we need to look at survival analysis, the whole concept of survival analysis. I wouldn't assume that many of us have known it, no. So I want to start from the scratch. Please, so if you've done it quite, if you are a professional, please, you can just allow some of us that probably are just starting to also learn, and you will learn one or two things too. Okay, so we are going to look at introduction. We are going to look at how do you create life tables in STATA, how do you plot the survivor hazard Kaplan-Meier curves, how do you fit it in the parametric and non-parametric regression models. So as a way of introduction, you hear a lot about survival analysis, time to event data. So if your research or if your study or if your work, no matter your field, engineering, sociology, sciences, and if your work needs the data that demands that the data you're collecting is a time data, and you have an event you are monitoring, you have an event you wish to that event will occur over a specific period of time, then you will likely do survival analysis. Survival analysis is a type of regression that is used to model time to event data. So we have linear regression, we have logistic, we have other types of regression models. But now, if you look at my slide, can we compare the mean time to event between groups of a given data set using t-test or linear regression? No, the answer is no. Because if you use t-test will only give you differences in mean of two groups. Linear regression will only model quantitative variable using specific predictors. It doesn't take into account time. It doesn't also take into account the events and whether people all had the events. So it can't account for that. So unfortunately, we can't use t-test or linear regression or even logistic regression. So because it ignores the principle or the issue of censoring. Now, also, can we compare the proportion of events in groups using odds ratio or logistic regression? Because no, the answer is no, because it ignores the element of time. Ignores the element of time. So I've seen a lot of people when they do the analysis, they try to use some other types of regression. But once I look at the data, I always query it. I will ask the person, so how do you plan to, sorry, someone is rotating on the screen. A minute, please. How do you want to account for the time variable there? So just a minute. Okay, so that's why we primarily are applying survival analysis in our data. Now, what is survival analysis? What does it mean? Survival analysis is a set of methods. It's not just one method. It's a set of methods used to analyze data where the outcome variable is time to occurrence of an event. As I've said it before, you want to monitor an event over a period of time, and you are monitoring it so closely that you want to know who. First of all, there must be a predefined event. Is it maybe in a clinical setting? Is it that the patient got well, or the patient died, or the patient had the disease again, or let me say, is it so as just an event, it must be defined. And then you want to monitor how long did it take for this event to be achieved. This group of people will now be followed up, and then you see some of them will not develop it. Some of them will drop out midway. Some of them may even withdraw from their study. So that is primarily what survival analysis and these methods will help you to account for. So it's a method of analysis of data that involves time to occurrence of an event. And it describes, that's number one, and it also quantifies time to event data. So it gives you a quantity. One will do to some of the practicals tomorrow. You see it in the life table. It gives you, if you look at the Kaplan-Meier plots, it will tell you these people are at true risk, these people are at high risk of this disease in events that your outcome is a disease or whatever. Okay. So where do we apply it? Where do we apply survival analysis? Of course, clinical studies and health-related studies, particularly in these study designs, cohort studies, in longitudinal studies, in clinical trials. So in industrial engineering is applied to study failure times. So I'm not an engineer, so I may not speak so much on this, but I know that you can always apply it here. In demography, we can use it to study the time intervals between successive childbirth. So if we can follow up a group of women and see how the interval between this child and this child and this child, so we can actually use survival analysis to model those outcomes. In sociology, we can apply it in duration of marriages, and for economics, in analysis of unemployment, duration of strike, anything that has to do with data, any data that has to do with time and an event. Yes, it can come in. Okay. So what is time to event data? You say there are measurements of elapsed time between the initial enrollment in a study and final disposition of the study subject. So I hope we understood this. Measurements of elapsed time. What is the period of time between initial enrollment in a study? So everybody is enrolled in a study together. Okay, please mute your microphone, please, when you join. Thank you. All right, so everybody is enrolled in a study together, and then monitored over a period of time. Some people may also be enrolled in that study at later times. So I will come to where we have the principle of censoring, where people enroll in a study together in a period of time, and then some other persons enroll at other periods. So you are looking at, did they all have the outcome? At what point did they have the outcome? So events could be time of death, time to relapse of a disease, time to recovery from illness, that's remission, length of stay in a hospital. Okay, so you are doing a PhD, want to monitor the events. The event outcome is the time you are going to finish your study. So the time you are going to probably graduate. So want to enroll PhD students in a cohort and then monitor them and study them over a period of 3 years or 4 years that they'll be doing their studies. How many of them were able to finish, and a whole lot of other stuff? How many of them dropped out? How many of them did not follow up? So in clinical studies, in health studies, sorry, as I've said before, we can use it in clinical trials, prospective cohort studies, retrospective cohort studies. Cohort studies are studies that are done over a period of time. You enroll people in a cohort, and either you go backward to collect their data, that's retrospective, or you collect their data fresh and must start monitoring them. Please mute your microphone, please. Thank you. Now, what is survival function? What is survival function? If you mentioning survival analysis, it has a function. So it's the probability that an individual survives from a time t to a specified future time t. So that is that probability. And then it's different from the hazard function. The hazard function represents the probability that an individual will develop an event at a time t. So an individual will survive from, just a minute. Okay. An individual will survive from this time to this time. That's the survival function. But that the individual will develop the event itself is the hazard function. So this speaks to time, while this speaks to the event. Now, the term failure is used to define the occurrence of the event of interest. So we usually term it failure. So when I share the data with you, you will see how we code the data specifically for survival analysis, because there is a way the data must be arranged in order to reflect some of this concept. And then the term survival time specifies the length of time taken for failure to occur. All right? So the survival function is different from the survival time. This is the probability, or this is the length of time itself. The failure is our outcome. That's our event. Okay? So these are important terminologies in longitudinal studies. The time, the survival time event I've said before is your failure. The time from entry into a study until a subject has a particular outcome. That's our outcome variable. Now, what is censoring? What does it mean to censor? Subjects are said to be censored if they are lost to follow up, or if they drop out of a study, or if the study ends before the outcome of interest occurs. So there are usually three things that can either happen when you follow a group of persons for a period of time. So if they are lost to follow up, yes, we've done studies where participants were lost to follow up. They changed environment. They couldn't participate in the study again. We did all we can to keep them coming, but they were not coming. So we couldn't follow them again. So at that point, we stopped. They didn't develop the outcome, but we had to censor them off of the study. Or they willingly drop out of the study. Of course, one of the core principles of research is that people can drop out anytime they want from your study. So you wouldn't always expect them to pull through. That's why we add attrition rates in sample size calculation, so that in events where people drop out, you can still have number that is almost close to your sample size. So, or if the study ends before the outcome of your interest, so they follow through the duration of your study, but they did not develop the outcome. So if the outcome is that they will die, they follow through, but the patient was still alive. So that is, they didn't develop the outcome. So all these three scenarios, the participant did not develop the outcome. So we all call them censoring. So we can't know the exact survival time exactly for this group of individuals. So this sensor data are represented by measurements for which we have some information about the survival time, but the exact survival time is not known. Now let's look at this. Let's look at this representation here. For example, hello everyone, welcome, thank you. Yes, I'm recording the session. The recording will be sent to your emails. Don't worry, the session is being recorded. Okay, so for example here, this study started at this point, expected to end at this point. So this is a participant. He goes through the study period, but did not develop the outcome. The outcome of interest is the X. That's your event. Remember, we said you always define your event. Your event, either that is expected that the patient to be alive. That's your event. Or is expected that a patient will die. That's your event. Or the patient will get better. Or the patient will, the disease condition will go. That's remission. That's your event. So whichever, in this place, say leukemia patient in remission. So you're expecting this patient that had blood cancer before for the cancer to clear off. So, but over the period that you mobilized them in the studies, you saw that they didn't it developed the outcome. So now, this is a better illustration. Now, let's study this very carefully. For patient number one or participant number one, we all enroll these people into a study that is meant to last. The time duration was defined that it will last from 1 week to 12 weeks. And then whichever point that the event occurs, we'll record it. Our event here is death. Now look at this first participant. He goes through this time duration. This participant started when the study began. Everybody was mobilized. This participant and this participant were all mobilized. They started at the same time. So, but you see, after the 5th week, the patient developed the outcome. So the patient died. That's the outcome. So we noted this. So the survival time for this patient is 5 weeks. Now, this is patient B. He goes through this. The study duration has ended. He didn't develop the outcome. So what do? We censor out this person. You are going to see how the data is in the next slide. For this person number C, he entered the study later. He entered the study at 3 weeks. And then went through the study for 3 weeks, 4 weeks, 6 weeks, and withdrew. He didn't start the same time this patient started. Okay? So the survival time is 3.5. For this number D, he started at this point and went through the duration of the study and did not develop the outcome. So this is, we censor this person, we censor this person, we censor this person. This patient number, participant E, was lost to follow up. So we couldn't follow him up and we dropped him off. And so, but he joined at the different time that this guy joined. He joined, so this guy, and this guy joined at different times. So this guy joined earlier, this one joined later, and this one joined later. But this one withdrew, this one did not develop the outcome, stayed at the end, and this one was lost to follow. Look at another participant that joined later at 8 weeks, and then was able to develop the outcome, died at 12 weeks. Or at, I think this is 11, it didn't get up to 12 here. So these are different scenarios that can occur when you are doing when you have this kind of data and you want to use survival analysis to analyze it. So if you look at study ends, no event, lost to follow, and withdrawal, these are the reasons why we censor out participants. We have 3 types of censoring. It used to be 2, left and right censoring, but there is an interval censoring. So I'm going to get to that. So how do we now form the data for this 1, 2, 3, 4, 5, 6 participants? So when I see your data set, look, this is what I expect to see. So for this guy, what is the survival time? And then did he develop the outcome? Do you remember that we said that did he develop the event? The event is failure. So we said 1. So the survival time is 5. If you look at him, he developed it. So this is how your data will be. For this participant number B, the survival time was 12 weeks. Of course, he was censored. So he stayed through the 12 weeks, but didn't develop the outcome. So he was censored. For participant number C, stayed 3.5 weeks. Also, for one reason or the other, couldn't follow through. So was censored out. Participant number D, like that. Also, okay, stayed for a while, and for one reason or the other, dropped out or didn't develop the outcome, was censored out. So E and F. So this is the way your data will need to appear when you want to do a survival analysis in data. You need to arrange it this way. The participant, the survival time, the events, you need to define the events. There should be another column here. The data that we are going to use for practicals contains another column where we define the event, and then you now add your censoring if there are people that did not reach the outcome. So I said that there is right and left censoring. What does it mean to censor right? A subject is right censored if it is known that failure occurs sometime after a recorded follow-up period. Now, look at this participant. There was an outcome here. There was an outcome here. We lost this person to follow up. This person, the study ended, he didn't develop the outcome. This guy withdrew, and this. Now, all these are right censoring. All these are right censoring. Left censoring is rare. This type of censoring is the one that usually occurs. It's the one that is short, that usually happens in most cases. Left censoring is rare. That one happens before the study starts. It depends on the type of study that you have. So left censoring, if the failure occurs sometime before the recorded follow-up period. So it's usually very difficult to see. It's usually difficult to see a scenario like this. Yes, everyone, thank you for joining. We are going to share the recorded session to you after the. Someone is complaining that the slides are blurred. Are the slides blurred? Sorry, can you see it? Is it fine?
From my end, they are not.
Okay, they're okay, right? Okay, thank you. Okay,
Yeah,
thank you.
I can see them. I can see them clearly.
All right. So I was talking about censoring to the left. Now, this is the start. This is your time period. HIV test. Now, before they even took the test and you started following them up, they have already they have already lost that. I don't know the kind of scenario where this can happen, but it's a possibility. It's occurred, the event occurs between 0 and T, but you can't measure the exact time. So, but mostly for all the analysis I've been doing, data I've analyzed on this, is usually the study will start and then we'll start monitoring. So that nobody can drop out or lose the outcome. Okay, so there is so at the end of this training, I'm going to also share this slide with you so that you can have it personally. If an event you need to go back to, maybe you are doing a presentation on this later, or you want to revise back and do personal studies, you can have them. So that's why I try to include so much in it, so that it can form a background for you. The interval censoring occurs when a subject, okay, he said a subject is interval censored if it is known that the event occurs between 2 time periods, but the exact time of failure is not known. Or again, this rarely happens. This rarely happens. What usually happens in most studies are usually the censoring to the right. Now, what is the importance of survival analysis? Why do we even do it? What advantage does it have over other types of analysis that we do? We say number one, it gives us an estimate of time to event. So it gives us what we call survival or hazard rates. It also compares time to event between more groups. So you have a group of patients that are taking this type of drug. You have another group of patients. Sorry that I'm always using patients because I have a medical background. Sorry. So you have another group that is exposed to another type of drug, maybe the placebo group, the control group, another people that are taking the real drug. So you want to now monitor them over the period of time. So in your Kaplan-Meier plots, you now see the plots for this group versus that group, and we are going to get to that tomorrow. So we will use it to compare time to event between 2 or more groups, and then to also assess relationship of covariables and time to event outcome, so using some form of mathematical modeling. We may not go that deep, but that is what it can be used for. Now, what are the methods of analysis of your data using survival analysis? We have the non-parametric method, the semi-parametric method, and the parametric models. In short, we call them models. Okay, just like we have linear regression model, logistic regression models. That's how we have it here. So the non-parametric models are the most popular. That's where you have your life tables, the Kaplan-Meier estimates, the Nelson-Allen estimator, a kernel smoother. So if you run through this slide, I did a screenshot of all the steps for you to actually do this on your own, because I knew that these 2 days may not be enough. The time we have may not be enough to do all that. So I demonstrated it in the slide. So, but know that the Kaplan-Meier estimator is a non-parametric model. The Cox regression survival analysis method is a semi-parametric model. We have the wearable, we have the exponential. I think there are other 2 types. They are all parametric models. So the difference between this method depends on the assumptions of your data distribution. Of course, we know what the a parametric test is. When your data is normally distributed, you are advised to do parametric tests. In a t-test, ANOVA, all those analysis are parametric analysis. But when your data, for any reason, is not normally distributed, or is an ordinal data, or a data that has maybe a score, or maybe is not doesn't follow a particular distribution, you are meant to be advised to go for a non-parametric analysis. So that's the same thing that happens here. That's the same thing that happens here. Okay. So for the Cox proportional hazard model, that's the one I call, sorry, the one I call the semi-parametric. Now, what is the practical application of Cox? When you want to see a car that is going at 20 mph meter per hour, varying traffic curves. So such type of analysis, where you want to determine the time that the speed, of course, speed is time that this car is going. The risk of road accident, that varies instantaneously according to traffic road condition. Another car going through exact the same route and traffic, but at 40 mph, risk of incidents is twice as much as every instant. So there are a lot more situations where you can apply the Cox. Well, the Cox, we are going to touch it a bit tomorrow, even though we are going to dwell more on the most popular, the Kaplan-Meier and the life tables, more than the Cox regression, because of the limit of time that we have. Proportional hazard ratio. In the proportional hazard ratio, the hazard varies over time, but the ratio of the hazards remains constant. I have defined what hazard rates and survival rates are in the preliminary slide. So the guy that introduced it in 1972 thought it good to introduce a method to calculate proportional hazards without calculating the actual time-dependent hazard. Okay, this proportional hazard can be adjusted for covariates. So where you want to adjust for covariates, there are covariates you want to adjust for. You should use Cox regression. All right. So these are the parametric survival analysis model that we have. Of course, I told you that we have the non-parametric, the semi-parametric, and the parametric. So, but these are different models on their own that we need time to delve into and explain. So, but for the sake of this training, if you look at the curriculum or what we had, so it's just an introductory course. So we are going to focus more on the life tables and the Kaplan-Meier plots, and also look at this and this other one, because they are the most used. They are the most used. Okay. Yeah. Okay, this is a parametric survival analysis model. Now, compared to Cox regression, there is an added requirement of checking appropriateness of choosing family of distribution to avoid increased effort with model checking. In parametric survival models, statisticians tend to prefer Cox model. So, instead of going for these parametrics, honestly, I read a lot of articles and I read a lot of studies. I rarely see some of these models being applied. Statisticians will either go for Kaplan-Meier or they go for Cox. so that they will avoid model checking, because you need to. I'm not a statistician by training, but I know that there is a lot of behind the scene analysis and assumptions. Many of these tests will need to go through before you can even do a particular type of analysis. Okay, so let's focus on the practical application of survival analysis using STATA, because that is what we came to learn. How do you do it, and how do you interpret your results, and how do you structure your data in the first place? So I wouldn't know if many of us use STATA here. If you are new to STATA, I will need to just do a quick introduction to. Please, I will take your questions when I'm done, please. I think I'll take your questions. I can't be attending to the two at the same time. Just when I'm done, I'll try and take your questions. Thank you. All right, so if you open STATA, these are what you are going to see. STATA has up to 6 windows. You have the command review box. You have your drop-down menu here. You have your output window here. This is where you have your results. And then you have your variable window here, where you see your variables. You have the properties of your variables here, and then you have your command prompts, where you input your command. So usually we put our command here, and then the command stores here, and then you see your output here. Before you do that, it's expected that you've imported your data. So once you import your data, you have your variables here listed at this variable view. So it can either import your data from Excel, from SPSS, or you open it up as a STATA GTA file. So open your STATA software if you have it. If your data is in form of STATA, you can just call it up. But if it is not, you can import it from Excel. So I'm going to drop the data in the command box for us to download now. So please, if you have STATA, please can just give me a minute. Let me fetch it and download and send here. Okay, someone is asking, how do you get STATA? I think you should go to their software, and STATA is a paid software. It's not like R that is free, that is open source. So you can, the last time I checked for LMIC, it's $220, I think so, thereabouts. So it's what, actually it is what the cost. Honestly, it is what the cost, if you can get it. It is. Okay. Just a minute. Let me drop the slides here. Someone is sharing his screen, okay? All right. Okay. So please download this and save. This is the data in Excel. Okay. Just download this and All right. So let's please can you download so that we can be on the same page? If you've done that, type yes on the chat box. Let me be sure that everyone got it. Okay, thank you. Thank you. Thank you. So that I can be sure that we're on the same page. Yeah.
Well, the upgrade now kwenye menyewe bi.
Thank you. So, okay, all right. Thank you. Thank you. This is the data we are going to use. Let me open it in Excel. Okay, so if you look at what we have here, we have this data that was collected from a group of patients in a study. Okay, this is the study time or the survival rate. So, and is in weeks. So it's in weeks. So this is in weeks. Now this is our. Hello, please mute your mic. Thank you. This is our outcome. This is our the group of patients. Those of them that received the placebo, those of them that received some other things that were not the placebo, maybe the control group and all whatnot. But this is their age and this is their sex. So the censoring data is not here yet. Not here yet. So I would have wanted us to do this, to just conclude, do the theory today, look at the rundown and steps, and then do the hands-on practical tomorrow. Because already I know I sent you guys a do file. I just sent you guys a do file where I have the commands that we are going to run for this session. So this command has always been used. So you can store this do file. Each time you want to do a survival analysis, you can refer to this do file. Yes, there is a sex variable in the data set. Anil, there is. There is. It's here. It's here in my own. Can't you see it? It's there. Please check. Okay. So we are going to run these commands and declaring the data is survival data, computing, how do you compute your life tables and how to interpret it, and how do you run your parametric regression model and a whole lot. So, but let's run through the, okay, let's run through the slides. Please reshare the do file. Okay, let me do that. Just a minute. Someone can, please, someone can send to, okay, someone can send to him. All right, so I've reshared it. You can have it now. Now, when you get to STATA, someone is asking, is STATA free? STATA is not free. I've said it before. STATA is bought in, you buy your own personal license, except you have a trial version. I think the trial version just stays for, I can't remember now, I think 1 month or so before it expires. So open your data in STATA if it's in STATA form. Oh, interesting. And then you open it. If it's in STATA form already, not in Excel, you open it and then you call it up. Remember that STATA data is opened as .dta file. You have the log file, you have the do file,
Sorry,
and
sir.
you have,
Sorry,
yes,
sir, for interaction. Where do we
yes.
get the data set?
I sent
Is
it onto
these
group.
example do files, example data sets in the STATA?
The data set is in Excel, just import. So I said here, if I'm just doing a demonstration before we do the actual practical, import the data set if it's not in STATA form. So I've sent it to you in Excel. So you can, if you don't know how to import, don't worry, we are going to do it. I'll teach you how to import, but I believe most
So
persons.
you shared in the email?
Yeah, no, I shared it in the chat. Did you just join now? Did you just join?
No. Okay, let
Please go.
me check on the chats.
Yeah, go through the chat box. You see there. Okay, so I'm sharing it again for the last time.
Thank you. I've saw them. I have saw
Okay.
them.
Oh, well, welcome. So you open your data here in STATA. You call it up if it's in STATA form. If it's not in STATA form, of course, you use your import tab, and you import it. Okay. Now, this is the data file because this data is is embedded in STATA. It came with STATA. So you can call it up from here. You can call it up from here. I didn't have this version, so I wasn't able to access it. So I provided the Excel file. This is the way we do file importation from Excel. Click on import, click on Excel, and then you have your data here. So once you have your data here, your variables will appear. So how you know that you've imported is that you have your variables here. They always appear here. And then this is your command window. This is your command, where you input your command. If you are new to STATA, we have a training that is coming up on the 10th of August. It's a comprehensive, I think it's an 8 to 10 days training. So just weekends only, Saturdays and Sundays, you can join in. If you are new to STATA, you can join in and register for that training. It will be shared on LinkedIn on my page. And then have a comprehensive, how do you analyze, how do you visualize, how do you clean data, how do you do all the basic things, parametric tests, um, um, bivariate analysis, linear regression, logistic regression, multinomial regression, ANOVA. So you're going to cover it in that course. So if you are new to STATA or if you are new to analysis generally, okay? So once you always import your data, whether you imported or you called it up as a STATA data already, what you do is that you go ahead and create your do file and create your log file. Your do file is where you save your commands. Your log file is where you save both your commands and your output so that you don't lose your output. Okay? So the log file is like a notebook, as if you are writing, it's like arrow script in R. So at the end of the day, you now have your do file as your log file as your result, because data does not save the components, these components together. So STATA will save your data differently. You can save your command differently. So that is why you use the do file to write your commands specifically, and in the log file you now have your results and your command. So this is an important steps you need to go through in your do file. Also, you can share it with your colleagues. It will save you time, and also you can always come back to see the commands that you have used. So, but sometimes, sometimes I'm always in a hurry, I may not have, I may not always, I don't always use do file to my day-to-day analysis, honestly. But if it's an analysis that I'll share or collaborate with someone else somewhere that we are working on the same data set, so I'll need to write up the do file commands and share with the person. So how do you create a do file? Just come to file here, click on do, and then you open your do file. and you create it. Remember, you need to import your data first. Okay? How do you create your log file? So come to file here, come to log, and you say begin. So it will either ask you whether you want to begin, you want to suspend, or you want to close log. So a log is like a record that you are keeping for your analysis. As you analyze, you see it. As you analyze, you see it. So these are what we are going to create tomorrow. So we are starting up with this. Once you join the session, you open your STATA. I wouldn't know how many of us that have this software. That's why I may not delve. Let's just run through the steps, and then tomorrow we do the hands-on practicals and we ask our questions. Okay? So your data exploration. You go ahead to do your data exploration. You describe your data, descriptive analysis. What is the if it's a categorical data, frequency and percentage. If it's a quantitative data, you check for normal distribution, check for a lot of equality of variance, and then you do your descriptive analysis. There are usually commands that we use. We have the code book, we have the describe, we have a lot of simple commands that we use to do data exploration. So you can either use your drop-down menu or you type your commands. So there are two, of course, there are two ways to look out for your data in STATA, the browse window or the edit window. So okay, so you have the list command. So you want to see what is the amount of data in this column. You use your list command. You have your describe, you have your code book, you have your D. The D is details. So you want to say summarize H, D. That's summarize H in details. You want to say describe this variable. STATA will describe the variable for you. It will tell you the type of variable that it is and all whatnot. Okay. So please, I will attend to your questions. Please just be patient with me. When we are done, I'll attend to your questions, please. Thank you. Okay. Now, these are the things the small analysis you can do. You can look at our age variable that is there. You can look at the frequency of the age. These are descriptive analysis that you can always do. So if you want to go through your drop-down menu, you can go through this place. That's the beauty of STATA. So in a situation where you don't remember the commands, no problem. There's always a drop-down menu to guide you. So you can always do that when you don't have the command on your head, or you don't know the exact command for what you want to do. So for those of you that will join the comprehensive course, I have a list of commands, virtually all the commands in STATA and their function. If you want to do this analysis, look at the commands, look at the type of data, look at the type of data that you apply that analysis for. Because I see many people always get confused. When they have their data, they don't know where and how this test, where do I apply it? How do I arrange my data for? If I want to run a multivariate ANOVA, how do I do it? On what scenario how do I arrange my data? And how do I interpret it? And what is the command? So I have that, I think I have that list of commands and everything. So that will help you. Now, when you are done with your descriptive analysis, you go straight to declare that your data is a survival data. You must do this. If you don't do this, data will not recognize your data as a time to event data, please. So when you come to this is the command for it. Say stset. Stset. We're going to do the practical, but just know that this is the way it flows. You declare your data as a survival data. That declaration is important. You can then, when you've done declaring, you can then describe it. You can then summarize. Okay? So how do you do the declaring? You come to survival analysis here. You come to setup and utilities, and you say declare data to be survival time data. So in case you've forgotten the command for it. Okay? Then, what windows and what boxes do you tick? Remember the failure data, the failure variable should be numeric, because the failure variable is not coded as dead or alive. Maybe your outcome, as the data that we have there, the outcome is dead. It will be coded as 1, 0. So the failure variable, that's the event variable, should be what? Numeric. It shouldn't be string. Because many times STATA sees string variables as read, and it wouldn't do much with string variables. Even when you want to run regression, if you don't encode your variables as numeric, STATA will not see it as numeric. So it may not be able to produce the output that you want. So once you follow these steps, declare your data as survival data, look at ST, you put your time variable here, you put your failure variable. So 1 is your outcome, which is your failure. Every other thing can be 0. Okay. Now, this is what you will have when you do. Please mute your microphone. Thank you. This is what you have when you do your declaration. So you will have this outcome. So it will say ST
Sorry,
data.
Kaisam, I have just a query. Can you repeat this
Okay.
last step? Thank you.
Okay. Which of the steps now? Should I go back? Should I go back a bit?
Yes, the where
Okay.
this drop down menu of survival is. Thank
All
you.
right. Thank you, Mohammed. Okay, so I said you click. Okay, let me start here. You click on statistics, survival analysis, setup and utilities. You come here. So when you come here, it will pop out this window. It will pop out this window. So I already show you how the data should look like. So that when you come here, you can now just drop and put your study, your duration data, that's your time data will be here. Your time variable will be here. Your events, you need to put it in a column. So what is the name of the variable and how did you code your event? Did you code it as 0 or did you code it as 1? You know, there can be many events. Now, if you're following up people for a long time, if your event is you want to see when they die, you want to see when this patient dies. So that is your event. So you can have people that were lost to follow up there. You can have people that withdrew there. You can have people that's just a lot of other events that could occur. But your main event is death. That's death. So you code it as 1. So that is the number you put here. Okay, welcome everyone. So, okay. So when you declare your data as a survival data, this is the output that you get. So STATA will tell you your survival time data settings has been successful. Your failure has been defined. Your observed time interval, 48 total observations. If you have any exclusions, it will tell you. So this is what you should expect to see after your declaration. Now, how do you create your survival table? We call it the life table. Your descriptive survival analysis. How do you create it? You come to your survival analysis here, click on summary tests and tables. You will go to life tables for survival data. So I did this slide in such a way that you just come to this slide, look at what you want to do. So far you've arranged your data properly. Just come here and do your point and click, and you have your result. Okay? So how do you create life tables? I've said that. What do you do when you come here? So ordinarily, if you're using the command, this is the command. This is the command. You put your time variable here. You put your event variable here, and then you click on survival table so that it can generate that table for you. And you say, okay. So you don't want it to be in a graph. You don't want to show you the graph yet. If you want both the graph and the table, no problem. But you just want to generate your life table. You click on that and it shows you what you want to see, which is your life table. So this is the life table. This is what we call the descriptive life table of your survival data. Now, I don't want to go into deep into describing this so much, but we are going to, as we do the practical tomorrow, I'm going to now, as we have the output, I'm going to explain what it means. Yes, the recording will be shared. Thank you. I'm going to explain what it means with respect to the type of data that we have. Okay? Okay, so you want to see by drug. Now, look at this command here. Study time, which is your time variable, your outcome variable, you say comma, survival intervals in 5. Here you want to see it by drug. So those of them that were placed on placebo, what is their life, this is their estimates. Those of them that had other treatments, this is their estimates.
Hello.
Yes, go ahead. Who is
Can you
speaking?
please repeat on that?
Juma. Okay.
Can you repeat on
So
that
I
process
said
of
the core,
analysis?
okay, the process of getting this table. Is it what you want to?
Yes.
Okay.
Yeah.
Just come to your statistics, come to survival analysis, click on summary, test and tables, and click on live tables for survival data. So that's the step, in case you don't know the command. Okay. So it will bring you here. You put your time variable, you put your outcome variable, which is the event variable, and you tick on survival table. So this is ordinarily this is the command. So, but in case you don't know, you've forgotten, or it's fine. Okay. So this is what I expected to see. I don't any hello? Anybody
So
want to
how
speak?
come? Yeah, yeah. How come I'm not having what's the name? I'm not having failure among my variables. So for the failure variable, it's not giving. It's only giving me the option of age and study time.
It's because you've not coded your data. You've not encoded your data. It's seeing that variable as string. That's what I'm saying. You know, this is just a rundown. When we come tomorrow, we are going to do it step by step. There is a step where you code that variable as 0 and 1. You code this as numeric. That's why it is not giving you the list of that variable in your drop-down list. Do you get?
Yes, I get it. Thank you so much.
And so, yeah, if you look at the color of that variable, you see that theta will give it red color. Yeah, Moses.
Yes.
Yes, thank you so much. When do we use intervals of 5, or is that a standard?
Yeah, it's a standard. Yeah.
Can we
It
use
is.
less than that? It's a standard, right? Okay.
It's a standard. Yeah, yeah.
Okay, thank you.
Anybody wants to ask question? Okay. Okay. All right. I saw someone's hand was raised up before. Okay. All right. So life table by drug. We're gonna see this. How many deaths, lost, survival, what's the survival estimate, and how do you interpret your survival estimate? Don't miss tomorrow's class, please. That class is going to be just purely practical. So if you don't have STATA in your laptop, please get it and see how you can get it, and please install. If you don't have it, you have the slides. Later on, when you get your software, you can practice. Thank you. Now, this is the Kaplan-Meier's survival curve itself. This is the command for it. This is the command for it. Kaplan-Meier's curve is a curve of time over your estimates. So you see the placebo group and the other group. So tomorrow I'm going to show us why do we have so many variations here. Someone is saying there is a way we can download STATA for free. Is that true?
Sorry, Kasem.
Oh,
I just
interesting.
wanted to Yeah, I am audible.
Yeah, go ahead. Go
Yeah,
ahead, Mohammed.
yeah, I have one question. So how can we uh do a Kaplan Meier by drop down menu in Stata?
Instead of command, right?
Yes.
Okay. Okay, I think I missed that in this slide. Oh, I'm so sorry. Could have shown you how that is done. Okay, so please remind me to know. Drop down menu, yeah, for Kaplan Meier. Okay. Ordinarily, every day I prefer to use commands. It's straightforward. So the drop down menu thing is not my thing. Honestly, it's not something I do every day, but it's fine.
Yeah,
Yeah.
got it. We are the beginners.
Okay.
Yeah.
All right, Mohammed. Welcome. Well done.
Thank you.
Okay, so I was talking about interpreting these estimates, and why do you have a steep here and you have a lesser steep here? So why is this curve above this curve? So we are going to now, there are these estimates that it should come with some numbers too, people that are low risk and people that are at high risk for it at each particular time point. So it comes with that too. Okay. Then your log rank test, in case you want to do your parametric survival model, which is the log rank test. This is the command. Okay. I went ahead to include Cox regression here too. Sorry, I missed out the drop-down menu for Kaplan Meier. Okay, sorry about that. I'm going to do that as part of what we have
Can
to
I
do.
help you on that, sir?
Yeah, hello? Someone is speaking.
Can I help? Yeah, yes. Can I help you if that's possible to solve the drop-down menu for?
Yeah. Thank you. Yes, you can.
So that you can find it under graph part.
Okay. Yeah.
And you can go to the surveillance graphs and you'll find it there. Thank you.
Okay. Thank you for that. Thank you. Okay, so this is the Cox regression. This is the drop-down menu for it. Survival analysis regression models, and this is your regression model. Okay. Now, before you do your Cox regression, you change the string variable to numeric variable. So if you import your data from Excel or any other source, maybe from a database, from an SQL database, anywhere, please, all string variables that are involved in your data, please encode them to to numerics, because strings are already text. Example, the drug is string, and STATA do not allow you to include string variable into your model, whichever, even if it's linear regression model. So this is how you generate new variables, and you say drug is 1, this is 4 for the group variable. Then replace this. So I'm going to I use generate. I also use another command called recode. I also use recode to do this. So I use recode. So at the end of my recoding, I can now say generate, and then all this, I will add it into my recode command. So those of you that use data, you know the recode command that we use to actually convert string to numerics. Okay. Generate gender, if you're comfortable with generate, no problem. When I started using STATA many years ago, I was using this command, but over time I found out that the other one was simpler. So it works easier for me. Instead of saying generate, replace this, you can just write it in a single sentence. Say recode, you put drug equal to recode drug, you open a bracket, 1 is equal to order, 0 is equal to plus, you close the bracket, you open another one, say, I think when we do it practical, it's not so clear in my head, but when we do it practical, you see how it works. And then After you close the last bracket, you say comma, generate drug2 or drug whatever new variable that you want to generate. Okay. So if you want to, of course, still continuing on cost proportional model, if you want to include your covariate, the covariate you want to include your model, this is a way you can do it. You come here, so you have covariates. That age you saw in that data set and the gender, they are covariates. So you want to include them as part of your model. You can do this and include them this way. So I think this slide is finished. Okay. I included, this is because this is an introductory class, I didn't want us to go to much of this, the covariates, the advanced stuff a bit. But if we have time tomorrow, I just wanted to keep it introductory the way it is. If you have time tomorrow, we can do this. And also, how do you do graphical? So you have this slide with you. You can check it out. I think it's time here. You can check it out later at your own leisure time. So I'm sharing this slide now. Please try and go over it. As you come tomorrow, we'll have a practical class together, and we look at some of these things and the way you interpret them. Okay. So let me quickly share it now. Thank you. So I'm going to stop sharing so that I can share this. Yeah. Okay, someone said I should share the data set again. All right. Okay. Let me share it again. Right. Post. I should share everything through the email. Okay. Would you prefer it in your mail? Oh, email. All right.
Yes, I think it's better you send to our mail.
Okay. You know, I had 1,000. I had as of this morning, I had up to 1,000, more than 1,000 people that registered for this course. So email, you can't share, can't send files. I think it's 500 is the limit or something. So, but I'll see how I can share it tonight so that by tomorrow you guys will have it. Is that okay, everyone? Thank you. So
It's okay, but
okay.
if you can also share now, if you don't mind, so we can
Yeah,
download now before
yes,
start practicing.
I've shared it here. Go to your chat, it's there. Please.
Thanks.
Or should I share again? Just go through the slide. I have done that. Yeah, the slide is uploading now. So I know there is no way I can finish everything that is in survival analysis within 2 days. We just 30 minutes class, 1 hour, 30 minutes class. So I had to do that elaborate slide. So I think the slide is coming up. Okay, yeah, so that's the slide that is uploaded. So you can have it. So someone said, can you give few examples of parametric data? Parametric data is your data that follows normal distribution. I hope you know how to check for normal distribution. I hope, do you understand what normal distribution? Will you have access to the recording? Yes. You have access to it tomorrow after the second class. So I will share it to everybody's email so I can watch and follow. Parametric tests are tests that parametric data is a data that follows normal distribution when you don't have a lot of outliers in your data sets. Outliers makes your data set to be skewed. So in such a scenario, either you use median and interquartile range, or you use your non-parametric test to do your analysis. You are not meant to throw the data away. You are not meant to throw the data away. You can also transform it. You have a lot of data transformation process there is a log transformation, there is a cubic square transformation, there is a lot of transformation that is available for you to transform your data that is not normally distributed to become normally distributed. But be careful with transformation because you lose the original data sets the way it is naturally. So that's one of the disadvantages of data transformation. But you can transform a data that is not normally distributed to become normally distributed. I've done it a lot of times. Or you just go for a non-parametric analysis. It's better. Yeah. So good night, everyone. I'll see you tomorrow.
Thank you very much.
Bye.
Bye-bye.
I hope
so
you
much.
learned
Thank
a
you.
lot. Yeah. See you tomorrow.
So much.
Bye. Thank
Yeah.
you. Good night.
Bye.
Thank you.
Good night, everybody.
Bye. Bye.
Good night. Bye.
Thank you.